Hello everybody. In this video we'll be discussing two applications of dimensions. In the previous video we have already discussed two of them, which were unit conversion and principle of homogeneity. So now in continuation to that we are discussing the third one today, or let's say it as the first one for today's class, which is checking dimensional consistency. Checking dimensional consistency. Now this is a very favorite topic of your as seen from the point of view of boards competitions. You will be rarely asked questions in this topic. So checking dimensional consistency, or you can say it is correctness. You check whether the given equation, they will give you an equation, you have to check whether it's dimensionally correct or not. So it's a very simple job to do that. You take the dimensions on left hand side. I am explaining the procedure now. So what you do is take the dimensions on left hand side, then you take the dimensions on right hand side. If they are equal, what you have to say is the equation is dimensionally correct. You have to conclude it this way, and suppose they are equal, you conclude it this way. And what if they are unequal, means they are not equal, you say the equation is dimensionally incorrect. Okay, so dimensions on left hand side is not equal to that on right hand side, then the equation is dimensionally incorrect or inconsistent, whatever you want to say. So this is very easy to do. We'll come to know when we do examples. Now let's try some examples. For that, if you want to note it down, you can do so. It's simple. I just explain you the procedure first. So the first example, let's take t is equal to 2 pi under root L by G. Okay, so let me define what the terms mean. T means time, L means length, and G is acceleration due to gravity, or simply you can say it's acceleration for now. Okay, now if you want to try, you can try. Like, you take the what's the procedure? Take the dimensions on left hand side, then take the dimensions on the right hand side and prove that they are equal, and think and check whether they are equal or not. Okay, so let's do that now. I'm doing it now. Left hand side, so let's go for left hand side, which is time. So it's simple as that. Okay, now let's go for right hand side. Right hand side, if you see, this is 2 pi. 2 pi is a constant, it is a number. Numbers are dimensionless, so we can remove this out safely. Yes. Now this root sign means it's raised to half. Told you in the previous class that wherever there is a root sign, you can replace it with raised to half. Raised to half. Okay, now let's write the thing inside the root. L. So L is for length. The dimensional formula of length is this. And acceleration due to gravity, or you measure it this way, we can reverse look at and say it is this. Okay, meters is length, second is time. Okay, length cancels. What we are left with is 1 upon t raised to minus 2. Now you get this t on top and change the sign. What will it become? It is t raised to 2, and then we have a half there. Okay, so what is this? This is t raised to 1. This 2 and 2 multiplied by half. So 2 cancels, you are left with t raised to 1. Now check or compare. Left hand side dimensions 1 in t, right hand side dimensions 1 in t. The equation is dimensionally correct. You are ending with the statement, the equation is dimensionally correct, or the equation is dimensionally consistent. Note down if you want to. Okay, now let's try one more example, which is f equals 6 pi eta rv. What is this, sir? Okay, I'll define it for you. F is force, 6 pi constant. Eta is coefficient of viscosity. If you remember, we had discussed about this, and the question has also provided you its dimensions, so no issues. You are safe even if you don't remember. Okay, the question has provided the dimensions. R is radius, okay, and V is velocity. So the question is the same, which is check dimensional consistency. Do try it, pause and try. Okay, now I'll do it. So let's go for the left hand side. So it says dimensions of F, which is force. Force is mass into acceleration, m, mass, acceleration, we know lt raised to minus 2. So this is the dimensional formula on the left hand side. Let's go for the right hand side now. Right hand side. Okay, now 6 pi. 6 pi is again a number. Numbers are dimensionless, so you can remove that out safely. Now dimensions of eta, dimensions of r, and dimensions of v. Okay, sounds nice. So eta, we have the dimensions. Even if you don't remember, I had given you a choice to remember other. Anyways, r is radius. So radius is basically a length, and then we have v. V is, let me create some space over there. Okay, so v was velocity, meters per second, or meter second is to minus 1. So those are that is the dimensional formula. Now look it wisely. M will remain as it is. There is no other m there. Now L, there are 3 L's. This is, look here, minus 1 plus 1. Okay, this will give this and this will cancel. Okay, and this L will be left, and this is t raised to minus 1, t raised to minus 1, t raised to minus 1, minus 1 plus minus 1, which is minus 2. Okay, so here we get t raised to minus 2. Let me repeat it if you didn't get it. So m is mass, so mass, you don't have any other mass, so I just copy pasted it down. Then go for length. Length, here you see L plus 1, L raised to plus 1, and L raised to minus 1. So when you add those, minus 1 plus 1, it becomes a 0, or you can cancel it. T raised to minus 1 and t raised, here there is also an L, so that I brought down, no other L now. And here we have finally t raised to minus 1, t raised to minus 1, minus 1 plus minus 1 gives you minus 2. Okay, now let's check this. The dimensions on the left hand side are 1 in mass, 1 in length, and minus 2 in time. And here also on the right hand side we get 1 in mass, 1 in length, and minus 2 in time. Same. So the equation is dimensionally consistent, or dimensionally correct, whatever you want to say. Congratulations if you did it correct. Now let's go for the third one. Third one is we'll use v is equal to p by rho. P by rho. What is this, sir? What is this rho? Okay, v is velocity, p is pressure. Pressure, sir, I don't know the formula, dimensional formula. So let me give you its unit. It's kg, meter raised to minus 1, second raised to minus 2. Yes, and rho is density, which is mass by volume. Basic. So you'll know its dimension. So I'm not giving you the units. Quickly try it. Just move out of the frame for 2 seconds. Okay, now I'll do it. Pause and try if you want to. So dimensions on left hand side, dimensions of v, or dimensions of velocity, which is meters per second, or lt raised to minus 1. Simple. Let's go for the dimensions on the right hand side. Now under root, so we can replace it by raised to half. Okay, now we have to go for pressure. Pressure is, they have provided us the units, so let's compute it through that. Kg is we can replace kg by mass, meter raised to minus 1, so L raised to minus 1, that is length, and second raised to minus 2 or T raised to minus 2. Okay, we have got the dimensional formula of pressure. Now let's go for density. Density is, as I said, mass by volume. You will know it from, so know it from very innocent ages. So mass by volume is L cube. If you see, length into breadth into height, whatever. Okay, so I brought that L up raised to minus 3. So let's replace the dimensional formula over here, ml raised to minus 3. Does anything cancel over here? Yes, m goes for m. Now we can't do anything, I guess. So bring that L raised to minus 3 on top. If you get it on top, change the sign, L to the power 3, and you have here L to the power minus 1 and L to the power minus 2. Okay, raised to half also we have. Okay, so now do it. Plus 3 minus 1, that gives you L raised to 2, and here also it gives you L to the power minus 2. And we have raised to half. Okay, let me do it somewhere else. From here I'll do it here, okay, on top where I'll do it. So L raised to 2 raised and T raised to minus 2, and the whole is raised to half. So get this half in and you are done. L to the power 1 and T to the power minus 1. So you multiplied this half to both the terms. L, you did it this way. If you want to see, T raised to minus 2 into half. Okay, this is the rough work. If you want to see, you took the half in and this is what you get. So compare. This is for right hand side, right? This was for right hand side. This was for right hand side. So right hand side we get this dimensional formula, and left hand side also we get the same dimensional formula, which means this equation is dimensionally correct. Wow. So let's try something different now. Now let's try some examples of this sort, which have plus minus signs in between. So v is equal to u plus at. Very famous, you might know it. V is final velocity, or you can just state it as velocity. U is also velocity, initial velocity, doesn't really matter here. A is acceleration as usual, acceleration, and T is time. So how will you do this now? There is also a plus sign in between. Is it confusing? No, let's try it. Let's try the same method. LHS, okay, dimensions of LHS, which is dimensions of V, and let's V is velocity, so LT raised to minus 1. Okay, now go for this right hand side, which means dimensions of U plus dimensions of AT. Okay, this is U, so velocity LT raised to minus 1, and here you have, here you have acceleration, meters per second raised to minus 2, or meters second raised to minus 2, so LT raised to minus 2, and here you have time. So let's simplify that. LT, so this is minus 2 plus 1, so minus 1. Okay, now are you stuck? No, it's very simple. You check the dimensions on left hand side, LT raised to minus 1, and if you know a little bit of principle of homogeneity, this is for you. If you don't know, I'll give you another way of thinking. Okay, don't worry. So those who know principle of homogeneity, this is for you. You just look if principle of homogeneity holds over here. Okay, so okay, V is LT raised to minus 1, here also U is LT raised to minus 1, AT is LT raised to minus 1. So principle of homogeneity holds, so you can safely conclude that the given equation is dimensionally consistent. Now for those who don't know what is principle of homogeneity, you can surely check the lecture 2 out. YouTube, do you have something to suggest? Yes. Okay, and you have one more method to look at this. Okay, let's try to picture that now. This is velocity, right? LT raised to minus 1. This is also velocity, lt raised to minus 1. What if you add two velocities? We are adding two velocities. What will be the answer? If I add 2 meters per second to 3 meters per second, it gives us 5 meters per second. But that is also a velocity, right? So when you add two different velocities, you'll get a velocity. So you can safely conclude that that lt raised to minus 1 plus lt raised to minus 1 will also have the dimensional formula lt raised to minus 1. Because when you add two similar physical quantities, although you can only add two similar physical quantities, but still, when you add two similar physical quantities, the answer which you get will also be the same physical quantity. Rather, you can only add two similar physical quantities. You cannot add something totally different physical quantities. To know more, do check out lecture 3, where I spoke on principle of homogeneity. Now let's try one more of that sort, which is v square is equal to u square plus 2as. So v is velocity as usual, u is velocity as well, final, initial, doesn't matter over here. A is acceleration and s is displacement. So quickly try it. Use the logic which we used in previous question. S is displacement. For 2 seconds I am moving away. Okay, now I'll do it. Pause and try. So dimensions on left hand side, which is v square, or v we know is l t raised to minus 1, and we have a square over that, so l multiplied to the each term. Okay, so this is what we get on the left hand side. Let's go for the right hand side now. Right hand side now, which means, okay, let's write that down first, or rather we'll write it this way. And 2 is a constant, we can remove it out, so yes, 2 is dimensionless. So this, if you see, it's lt raised to minus 1, and we have a square over it. Here it's acceleration meter second raised to minus 2, or lt raised to minus 2, and displacement is basically a distance, or not distance, it is a length. Now you can check that, multiply 2 to each term inside, power of each term, and here L, so 1 here, 1 here, 1 plus 1, 2, L2 t raised to minus 2. Now you can check it out. Those who know principle of homogeneity will say v square has, okay, this dimensions, u square has this thing which is same as that, and even this term has the same dimensions. So principle of homogeneity holds, and we can safely conclude that this equation is dimensionally correct. Or the second way, which in which we say, okay, we are adding some, this is something L2 t raised to minus 2 and L2 t raised to minus 2, so we are adding two similar physical quantities. The answer will have same dimensions as those of the sums that we had added, those of the quantities that we had added. Okay, so you can either look it in the way of principle of homogeneity, or you can step back and say that when you add two similar physical quantities, the dimensions of the answer will be the same as those of the previous. Okay, now let's try one more example, and we'll wind up with this application and move to the next application. S is equal to ut plus half at square, also a famous equation. So S is displacement, u is velocity, t is time, and a is acceleration. Quickly try it. You have to use the logic in the previous question, either principle of homogeneity or basic basic knowledge. Okay, so I'll do it now. Dimensions on left hand side, which are dimensions of S, which is displacement. Displacement means it's basically length. And then let's go for the right hand side now. So dimensions of ut plus half is a constant, so even if we remove it out, it won't have any effect on dimensions. Okay, right. Okay, so now let's simplify this. U is velocity, and now we know what velocity means. L A is acceleration, meter second raised to minus 2, L T raised to minus 2, and we have t square over there. So t square, time square, t is time, t is time. Now minus 1 plus 1 0, so t raised to 0. Even if you don't want to write that, you can simply state it this way. And now here also minus 2 plus 2 L. So now you can either go by the principle of homogeneity way, which says S, the dimensions of S, which is L. Okay, the dimensions on the left hand side of this term is L, of this term it's also L, and of this term is also L. Principle of homogeneity holds. Conclude that the equation is dimensionally consistent. Or if you wanted to look at this, look it in this way: L plus L, 2L. No, L plus L means the dimensions. It means dimensions, right? Length plus length. So when you add two lengths, the answer is a length. The answer will have same dimensions as that of length. You can't add two length and you can get something in time. You can't have that. Okay. If you add lengths, you will get length. What you give is what you get. So let's now move to application 2 of today's lecture, which is establishing relationship. Before your innocent mind jumps into thoughts, let me complete my sentence. Among physical quantities. Okay. So they'll give you that certain quantity depends upon so and so quantities. So you have to derive a formula for it. Interesting, right? So let's I'll explain you the procedure directly through an example. So here is the question 1 on board. It says time period of a pendulum. Those who don't know what a pendulum is, it's somewhat like this. You might have seen it in clocks. Okay, even if you have a string with a stone tied it at the end, so that also becomes a pendulum. So the time period, you give it an oscillation, so it has certain time period. Okay, so that depends on the length of the string. This is the length of the string, mass of the bob. So this, the stone that I spoke of, will have some mass. Okay, so that depends on the mass as well, and acceleration due to gravity. So derive the relation. Okay, so we have, I'll tell you the step by step procedure now. So they have given us time period depends on so and so things. So you write time period is proportional to, now you might know this sign. This is a proportionality sign, not of much concern. Okay, let's continue. So proportionality sign, and then depends on length, and we don't know the powers, whether it's directly proportional, like if we increase the length it will increase the time period, or if we decrease the length it will decrease the time period. For now we don't know that, so we'll directly write it as L raised to A. It can be positive, negative, so accordingly we'll get it is directly proportional and indirectly proportional, whatever. Okay, so we'll write L raised to A, M raised to B, whatever the quantities are you write, and G raised to C. So you write it this way first. This is the step 1. You write a proportionality equation for the formula which you want to derive, that this quantity is is proportional to, not directly, sorry, is proportional to L to the power A, M to the power B, G to the power C. Now you replace that proportionality sign with an equality sign. What do you do to do that? You multiply a constant. Let's say that constant is K. Okay, we'll say that constant is K. If you didn't know this, that if you change proportionality sign to equality, you have to multiply a constant remember it from now, that whenever you change the proportionality sign to equality sign, you have to multiply by a constant. Okay, now let's take dimensions on both the sides. So take dimensions over here and take, this is a constant, so we know it's a constant. Dimension less constant it will be, so it will fly off. And this is length, so L raised to A. This is mass, so M raised to B. And this is acceleration due to gravity, which is LT raised to minus 2, and it's raised to C. Okay, so now what you do is, now you write it in single brace, so M raised to B, L raised to A, and here you have L raised to C. Okay, that gives us L raised to A plus C. Now L raised to A and L raised to C, yeah. And here you get T raised to minus 2C. This C I got in, and this A also I got in. Okay, now this time you can also write it as M0, L0, T0. Oh sorry, T in 1. It's time, no? So 1 in T. Okay, so others are 0, it's fundamental. So now you have to compare this M and this M. So M raised to 0 and M raised to B. So the bases are same, so powers should also be same, which means B is 0. What did I say? M and M on left hand side and right hand side, the bases are same, so the power should be same. So 0 is equal to B, so or B is equal to 0. Here also L and L bases are same, so the power should be same. So A plus C equals 0, or you can say that A is equal to minus C. Okay, now let's look for T. T has a power 1. Nothing is shown, that means 1. Okay, 1 is equal to minus 2C. So C is equal to minus half. Wow. So you got C, you can get A from here. So implies A is minus of C. So you put minus of minus half. So that gives us half. B is 0, A is half, and C is minus half. Okay, now just put that over here, so you get the formula directly. It's very easy. K, so K that we won't be able to derive through dimensions, it's a limitation, we'll come to it in the next class. So L has the power A. What is A? A is raised to half. Wow. And sorry, L is raised to half. L is to the power A, so L raised to half, A is half. M is 0, B is 0, so it does not depend upon the mass, though they have given it that way just to add a little spice to the problem. Okay, anyways, G is acceleration due to gravity, which G is raised to C, so C is minus half. Okay, can we write it more clearly now? Let's create some space on top, we'll say. Okay, so let's write that down. T is equal to K. M is in 0, so we can remove it. It's M to the power 0 means 1. And L we have raised to half. And now this G is raised to minus half, so we can take it to the bottom in the denominator and change the sign. So we took it into the denominator and changed the sign, which was minus earlier, to positive. Okay, but what is raised to half? Raised to half, what does raised to half means? We can also write it this way, L by G, both are raised to half. What does raised to half mean? Recollect. So it means root. So you got the formula. It's finally what we get is T is equal to K under root L by G. So you cannot determine that K through dimensional analysis. Through experiments, it was found that K is 2 pi. You have to end your answer over here. So T is equal to K under root L by G. Let's repeat the procedure once in a quick while, so we can think of it for the next problem. Okay, first we said time period is dependent on so and so, so we write a proportionality equation we say t is proportional to all of those quantities L raised to a. These are some random quantities of which we need to find the value, so we get the formula then. Okay, so L raised to a, m raised to b we say, and g raised to c. Okay, now when we change proportionality sign to equality, we have to multiply a constant, so we multiplied that. Now that was the second step. Now taking dimensions, now this is a constant, dimensionless constant rather, so when you take the dimension it flies away, and you take the dimensions, then you simplify. Yes, here we simplified, and last step is to compare and get the values. We compared b is 0, we compared a plus c is 0, t raised to 1 we compared with this, and we got the value of c. Then we solved it some way, means a is equal to minus c, so from c we got a, and we have all the values a, b, c. Okay, then we resubstituted it over here. From here we went here and plugged in the values of a, b, and c. We plugged in a as half, c as minus half, and b as 0. Okay, and finally by solving we got this. So this is the formula that we want. Even if you don't write this, that k is 2 pi, it was experimentally determined. There is no way you can find it through dimensions. You just end the formula over here. Okay, it says the frequency of a stretched string depends on the tension force. So you have a stretched string of whose frequency they have provided you the unit, so you can derive the dimensions. Okay, it depends on some tension force, some force, and mass per unit length of the string. So you divide mass by length of the string. Okay, so it depends on mu, so this they have called as mu whatever, and then they have also said that it depends on the length of the string. So you can quickly try this out, pause and try. Okay, so the first step, what do we do? F is proportional to all the things. Now tension force, will take this as T. Okay, we'll take it as T only, and T raised to A. Then mass per unit length, they have told mu raised to B, and finally the length of the string, which is raised to C. Okay, now change the proportionality sign to equality sign. T raised to A, mu raised to B, and L raised to C. Okay, now what do we do? Take dimensions, frequency, and this is a dimensionless constant, it flies off. Here we have T is tension, not time. M, so it's a force, tension force. So mass into acceleration raised to A we have, so A will get multiplied to each of the powers, and here we have mu is mass per unit length, or the formula is this. So M, we got that L on top is to minus 1, and B, and finally the length of the string, which we can simply say it as L because it's a length. Okay, now let's solve for this. Frequency, they have provided us the unit, so second raised to minus 1, so T raised to minus 1. You can also write M0, L0, just in case if you want to compare. Okay, so you have two m's over here, 1, 1, so 1 plus 1, 2. No, sorry. This m is raised to A, and that is raised to B. You multiply this in, no, and then you see it. Now L raised to A, L raised to minus B, L raised to plus C. So what do we get? L raised to A plus, this was L raised to minus B, or let's say minus B, and here you get L raised to C plus C. Okay, now let's go for this. Now T, only one you have. Okay, 2A, yes. So the best way to compare is to look for the least variable. So here there are two variables, here there are three variables, and here there is just one. So you just directly go for T raised to minus 1 you have. So bases are same, so power should be same. So minus 1 equals minus 2A, or A equals half. Okay, so directly we get the value of one of those things. Now let's look for the values of others. So what we got a. Now let's go for two variables. A plus b is, so m bases are same, power should be same, so a plus b is 0, so a equals minus b, so, or you can say minus a equals b, so b equals, here it is half, so its minus is minus half. We also got the value of b. Okay, let's go for c now. So here we can get c, a minus b plus c equals LL, bases are same, power should be equal 0. So we also have b, we have a, which is a is half, b is minus half, so minus and this minus, write it down, plus c equals 0. So you have this half plus half, which is 1, and you have this c is equal to minus 1. Now what do we have to do? We have to resubstitute it over here. So we get f is equal to k, and we get t is raised to half, so t is raised to a, which is half. Now mu is raised to b, which is minus half, mu is raised to b, which is minus half, and L is raised to c, which is minus 1. L is raised to c, which is minus 1. Now can we simplify this even more? Okay. Where can I do it? Let's look for some space. Okay, I'll do it here. I'm removing this proportionality equation. Okay, from here I came here. F is k, which cannot be determined this way. Now this is raised to half. Okay, this is minus, so whatever minus terms are there, you take it in the denominator and change the sign. So t raised to half you have, also mu raised to half, so both of them are raised to half. I took this mu down and it was minus, so it became positive when I took it down, and both of them are raised to half. Okay, and this L also I'll take down, so it changed the sign, it was minus 1, here it came down and it became plus 1. So you can write it as k by L. What is raised to half? Under root. So this is the formula. Here directly you can say f is equal to k upon L under root t by mu. So this k cannot be determined, of course. For a string it will be actually 1 upon 2, I guess. Okay, so this is the way you do it. Let's try one more example now. The question 3 is on the board, so let's read it. Centripetal force acting on an object. This is some force acting on an object, depends on the mass m. So centripetal force is actually when if you take a stone, you tie it, if you take a thread, you tie it to a stone at the end and you revolve it. So the force which acts here, which acts towards the center, is centripetal force. So it's revolving it into a circle, so that is the centripetal force. Anyways, if you didn't know, so that depends on the mass of the object, the mass of the stone in our case, which I spoke of, its velocity, with how much speed you rotate it, velocity, direction also matters, and radius of the circular motion. So what is the length of the string or the radius in which you are rotating the stone. Anyway, so let us derive equation for it. You can surely pause and try before I start. Okay, what is the first step? Write a proportionality equation. So force depends on mass raised to a, which we don't know what it is, velocity b, okay, and radius c. We'll say r, they have given as r, c. Now change the proportionality sign to an equality sign, multiply a constant k, m raised to a, v raised to b, r raised to c. Okay, now take dimensions, so that is dimensionless constant, it flies off, m is raised to a, so m is mass, doesn't make any difference. Velocity lt raised to minus 1 raised to b, and finally radius, which is l raised to c. Okay, so this is force. force has dimensional formula m l t raised to minus 2 mass into acceleration for now. Okay, and here you have m raised to a. L you have twice over here. Here it's L raised to b, and here also it's plus c. L raised to b plus c, and here you have t raised to minus b. It's minus 1 into b, so minus b. So either you can compare this or this because it has only one variable. Let's compare for a. So base is same, powers will be same. So a is 1. Here it's 1, here it's 1. Whatever. If I don't mention, it's 1. Here now you can come t raised to minus 2, and here you have t raised to minus b. So minus b is minus 2, or b is 2, you can say. B is 2. Good. And let's go for L now, since it has with the variables. B plus c equals 1. So here it is 1. B plus c equals 1. Base is same, equate the powers. Okay, we have b, we have the value of b is 2, and c we need to find. So c is minus 1. You solve this, okay, and you get c is minus 1. So we got the values a, b, c. Now it's easy, very easy. F equals, you come over here this step and just plug in the values. M raised to a, so m to the power a, so a is 1. V to the power b, to the power b is 2, and r to the power c, r is minus, c is minus 1. So you can remove that minus sign by taking it to the bottom, mv square by r. So the proportion k here is 1. You are supposed to end the answer here. Okay, it's correct. So it's very simple, same procedure, same way. You just have to find ABC and then plug in over here, you get the answer. There is one more type of this sort, but I'll give you a homework before it. So the homework question is on the board. I'll just write the proportionality equation for you. It says potential energy of spring depends on spring constant, which has a unit of meter raised to minus 1, and extension of the spring from its natural length. So extension is basically length, so it has the same dimensions as that of length. So I'll write the proportionality equation. You have to do it as a homework. So potential energy, I have taken it as U, is proportional or depends on force constant. Let's take it as K. So it depends on K, and extension from string they have said X. Now take the proportionality constant as C or something, because you don't want to mix it up with this K. Okay, do try it and let me know the answer in the comment section, and you'll receive a heart from me. And don't neglect it as usual. Nobody answers in the comment section. Okay, this was k raised to a and x raised to b. This is the proportionality equation. Then you have to solve and get the values of a and b, and same procedure, and let me know the answer in the comment section. There is one more sort of question which is under this type only, but they are framed a bit differently. So just to confuse you, so it goes this way: if force, length, time are taken to be fundamental, then write the dimensional formula of density. Okay, this is from the book H.C. Verma. You can surely try it. Well, it's just framed differently. So they say instead of taking mass, length, time as fundamental, you take force, length and time to be fundamental. And tell me what will be the answer for dimensional formula of density in that terms. Okay, let's try it now. What do we have to do? We have to go it in the same way. You have density, so let's take some letter for that. Let's take rho for it. Rho will take F for this, will take L for this, and T for this. Okay, now same procedure, just the question is framed differently just to confuse you. So okay, so F raised to A will say L raised to B and T raised to C. Okay, now change the proportionality sign to this. F is 4, so M L. Okay, wait, we have not taken dimensions yet. F to the power A, L to the power B, T to the power C. Now take dimensions. So this K flies off as usual. Dimensions of force, ml t raised to minus 2, dimensional formula. And L we have length, so L time is t, here it's raised to B, raised to C. Now density, as we know, mass by volume, or ml raised to minus 3. Okay, now come here. M, there is only one M, so we'll directly get it as A, M raised to A. L, we have A plus B, so L is A plus B. T, we have T raised to minus A, T raised to minus 2A. And here also we get one more T, which is plus C, which adds to this. Now the least number of variables is here, and so M, same base, equate the power. So A, you get it to be 1. Okay, now let's go for B. B is B is A plus B, will say A plus B. This is length, L raised to minus 3. So this should be equal to L raised to minus 3, and A is 1, we know that, plus B is equal to minus 3. So B is minus 4. Very good, we also got it for that. And finally we'll say T raised to power 0. So T to the power 0 over here, it's, if nothing is written, it means this, T to the power 0. So minus 2A plus C is equal to 0. Now minus 2A equals minus C, or you can take that 2A that way. So C is equal to 2A, C is equal to 2A, but A is 1, so C is 2 into 1, which is 2. We got all the values A, B, C. So we can finally write this as density is K F to the power 1, A is 1, L to the power B, which means L to the power minus 4, and T to the power 2. Or they have asked us for dimensional formula, or you can write it this way. K again flies off. F L to the power minus 4, T to the power 2. Same question, framed it in a different manner, right? So let's try one more sub question. So I've just changed the question a bit. So this first, all of the two sentences are right, two lines are right. I've just changed here energy in place of density. I've put energy, and I have provided you the options as well, so you can try it. So you can try it. Be quick. Okay, you can pause and try now. I'm doing it. So I will do it with a different approach now, not by the same approach. Since options are given, I can do one more wise thing. I'll give you two methods for this. One which I call superstar method, and one is this one more good method. So this is for that superstar method. Superstar method. Here will come to checking options. Now you can do a very wise thing, that you can check the options, like what are the dimensions of energy. You already know this, m L2 T raised to minus 2. Okay, same as work, joules, or you can also, yes, joules. So You can also compute it from half mv square, so mass into velocity squared. So you can find the dimensions from here of the quantity which they have asked for. Now compare it with the options. So the option which gives this dimension formula is the correct option. So F into L. So force we know, mass into acceleration. This is this. Oh, the first one is correct. So M L plus 1. Yes, first one is correct. Now let's prove this as wrong since it's a single correct option. M L t raised to minus 2, and here also we'll have, so it's squared, right? So L square, so 2 plus 1 3, so that does not match, it's out. Here also you can see ml raised to minus 2 and you have t, so ml1 t raised to minus 1, so that also does not match. Now you can go for this one, ml t raised to minus 2 l raised to minus 1, so both of this will cancel, but we want l square, so that does not match as well. So one wise thing is to check the options. If you are not given the options, you have uh, either the choice of first way which I spoke in the case of density, or you can go by the superstar method, but it won't be approved because it's just manipulation. The superstar method is just manipulation. Now let's try the superstar method. So we'll say energy. So what is energy? Okay, we can either say energy, or we can do a very wise thing. We'll give this term a term, we'll say E. Okay, so we'll use E for energy. We'll take the dimensions, but we already know that the dimensions of energy are same as that of work. Both of them are measured in joules, so both of them have the same dimensions, which is this. You can turn your pages and check. Okay, so dimensions of energy are same as that of dimensions of work. But what is work? Work is force into displacement. Displacement is length. Okay, if this method is like confusing you, you already have two methods with you, one which works with options and one which works without any options, so you can prefer any of those. This is a method for pros only. Okay, this is for pros only. Okay, so let's come back over here. So we got force, now we have length. Okay, done, the job is done. We don't need time, or we can also write it as fl t raised to 0. Job done, right? Let's try it for density as well, since this was a bit easy through the superstar method. Let's try it for density, f the previous question I'm speaking of. So rho density, we know it as mass by volume, so mass by volume. Now what can we do? Now you have to think and manipulate it. So we need force, we have mass, so into acceleration we can do, right? So take dimensions first. So we have mass. What do? We multiply acceleration both on top. I'll directly multiply the dimensional formula of acceleration. So both on top and at the bottom. So I multiplied that. So at top it gives me force, mass into acceleration. So this is the dimensional formula of force. Okay, and at the bottom I have L to the power 3. So let's compute that, L to the power 4 and T to the power minus 2. So F and what? Oh yes, done. Length and time. So this is so simple, right? If you could get it. Okay, so this is very wise manipulation. It's only for pros. Beginners prefer either this method or the previous one, which is very basic, and you'll get the answer within some time. So that's it for today's lecture. If you made it this far, do drop a like and subscribe to my channel. Thanks for watching.